Internal combustion engines can be broken into two basic types, and we often commonly talk about those two types of engines as gasoline and diesel. And we talked about how that's kind of short-sighted because we use a lot more different kinds of fuel than just gasoline or diesel. So a better way to differentiate between those two types of engines is to talk about a spark ignition engine or a compression ignition engine. So the spark ignition is the gasoline type fuels, and the compression ignition engine is the diesel type fuels that we put in those engines. So what I'm going to do in the next few minutes in this video is to go through that and get an understanding of how the differences between these two types of ignition systems, those two types of engines. So to do that, we'll look at spark ignition, compression ignition, but first we have to look at some basic fuel properties. Specifically, what we need to understand is the auto ignition property of fuel. Auto ignition means the pressure at which the fuel-air mixture will auto-ignite. What does that mean, auto-ignite? Well, here's the deal. If I take any type of an air-fuel mixture, so similar to what we were pulling into an engine or what we're combusting in an engine, if I took that air-fuel mixture and I pressed and pressed and pressed and pressed and compressed it, eventually, if I pressed it enough and got the pressure high enough, it would auto-ignite. It would just burn on its own without any kind of spark or flame or anything to make it burn. It would burn on its own. So that's what we call auto-ignition. Auto-ignition means I'm going to compress that air-fuel mixture enough, get it above that pressure, and that's when and it will auto-ignite. It'll burn on its own, okay? So what is that pressure and how do we do that? Well, we're going to come back to this later in the semester, but the octane rating, and if you go to a fuel pump and pump fuel into your gasoline into your car, your automobile, your pump, you have a choice of different types of octane ratings. So there's 87, 89, 93, something like that, different octane ratings. Well, these octane ratings is an indication of this auto ignition pressure. That's what octane is. So a higher octane rating on gasoline means a higher ignition pressure. So that means if I have 87 octane fuel and I compress it to a certain amount, then it will auto ignite. But if I put 89 octane fuel in there, I can compress it a little bit more before it'll auto ignite. If I put 93 in there, I can compress it even a little bit more. And so what the octane is an indication of what pressure that fuel is going to auto-ignite, okay? Now, we have the same kind of thing for diesel fuel. It's not very common to talk about that. You don't see cetane ratings on a pump, on a diesel fuel pump, but we do have the same kind of thing for a diesel engine, but it goes the opposite way. So a higher cetane number is a lower ignition pressure. And again, we're going to come back and talk about these a little bit more, but that auto-ignition pressure is the key thing that differentiates between spark ignition and compression ignition engines. Here's why. So let's start looking at spark ignition engine. Again, this is gasoline engines. Most of your automobiles that run gasoline, they're all operate on spark ignition. Most little small engines, the ones we'll work on in lab, they are spark ignition. They have a spark plug in them, and that's what ignites the fuel. Okay, so what's going on here? So one of the fundamental differences between spark ignition and compression ignition engines is that typically in a spark ignition engine, the air-fuel mixture is compressed in the piston. Okay, so when this piston comes down on the intake stroke and it's pulling something into the engine, it's pulling in an air-fuel mixture. So somewhere upstream from this piston in this engine, I'm going to mix the air and the fuel together. So what's actually going into this piston is an air-fuel mixture. So I compress that and compress that to a certain amount, and then I ignite it with a spark plug. So I have a spark plug over here, and that's going to provide a spark. That's what's going to ignite that fuel. Okay, so let's think about this. We said that the fuel, if we can compress it enough, it will auto-ignite. So think what would happen in this engine if this was compressed and compressing and compressing, and before that piston got all the way to the top, it surpassed the auto-ignition pressure and that fuel ignited. What's going to happen? Well, that's going to want to burn funny. It's going to actually push down. That piston's still coming up, but I've got pressure that's pushing down on that piston, and so things are going to be fighting with each other. And when we have an engine knock, you'll hear an engine, we'll talk about an engine knocking, we'll get a rattling sound. So it'll rattle and bang and sound bad. Sometimes you'll hear this when you're lugging an engine really low and making it work really hard. You'll hear the thing start to rattle and go on. That's knocking, and a lot of that can be problems from auto ignition, that engine is slowing down. I'm getting pressures really high, getting a lot of heat in there, and that fuel is igniting a little bit before it's supposed to. So that's the bad part of it, okay? So we have to limit, we have to watch what our compression ratio is in a spark ignition engine. We don't let it compress too much before we ignite it. So again, key differences: air-fuel mixture is compressed in the piston. So when we intake, what we intake into the piston is the air-fuel mixture. We compress it. Hopefully we don't compress it till it auto ignites, and when that piston gets up to the top or close to the top at its optimal point, that's when we're going to ignite it with this spark. And the spark will make it ignite when we want it to, and the proper timing at the proper cycle, a proper point in the cycle in that rotation. Okay, so that's the key difference. That's the key thing about a spark ignition engine. So fuel delivery typically is carburetors. So we'll talk about carburetors, and our small engine that we'll work with in lab has a carburetor on it. We'll tear that apart and look at it. But that's what mixes the air and the fuel together. So we have an air-fuel mixture going into our engine. We can have some fuel injection. I'll talk about that later, what fuel injection is. We can do some fuel injection, but typically it's a carburetor, mixes that together. We have the spark that ignites it. Compression ratio in our spark ignition engines is relatively low compared to compression ignition engines. So typically less than 10 to 1, and different books will tell you different ranges, but that's the ballpark of where you're at. So 6 to 1, 8 to 1, something like that. So your typical small gas engines, the one we work with in the lab, is usually around 6 to 8 to 1, something like that. 6 or 8 to 1 on the compression ratio. So relatively low compared to compression ignition. Now, let's look at compression ignition. What's the difference? All right. So here in a compression ignition engine, air only is compressed in the piston. Okay. And look here, we have compression ratios 15 to 20 to 1. So much, much higher. Where the spark ignition was only a 10 to 1, these go up to 15 to 20. So very high compression ratio. So if I would have that air-fuel mixture coming into this compression ignition engine, very, very likely, because of that high compression ratio, it's very likely that that fuel would auto-ignite long before that piston got to top of its stroke, and it would rattle and bang and push the piston down, if it would even operate. Sometimes they won't even operate because it burns too early and pushes the engine backwards, and it can really damage an engine. Okay, so we cannot use something with a low octane, or that low auto-ignition pressure in a compression ignition engine. So diesel fuels have a much higher auto ignition pressure. So how do we ignite it? So on the intake stroke on this engine, when this piston's coming down, what we're pulling in is clean air, no fuel, just clean air. So we pull the air into the piston at the bottom of the stroke. The piston comes back up. It compresses that air. When it gets to the top of its stroke, or very close to it, or wherever the optimum point is, and we'll talk about timing later, that's when we're going to squirt the fuel into the engine. So we have an injector, so it's a high pressure. It's got to work against high pressure because I have fairly high pressure above this piston here. So that injector has got to inject that fuel in there at a pretty high pressure, like orders of thousands of PSI, so pretty high pressure. So we inject that fuel in there, we atomize it, so we want that fuel to come out in little droplets, and as soon as that fuel comes out and mixes with that air that's in the top of that piston there, that pressure is already above the auto ignition pressure of that fuel. Boom, it ignites, it burns, gives me that pressure in there that's going to give me my power stroke that's going to push that piston back down. Okay, so spark ignition, we light it with a spark. We compress the air-fuel mixture. That's the key thing. We compress the air-fuel mixture. We ignite it with a spark when we want it to go. Okay, in a compression ignition engine, that we compress air only. So what is getting compressed is only the air. in the top of that system, and then we inject the fuel in it when we're ready for it to ignite. The pressure is already going to be above that auto ignition pressure. The fuel is going to ignite, give me my pressure, give me my power stroke, and away we go. So that's the fundamental differences, the things that you guys need to remember. So what's going into the engine? Air or air-fuel mixture. What is the compression ratio? Much higher on compression ignition engines than on spark ignition engines. And those are the two main things that what goes in, compression ratio, and then how we ignite it. So it's ignited. One is ignited with a spark. One is ignited simply by the compression, by the fuel being compressed.